Okay, cooling and heating loads. So, kita nyo yung mga cooling load components. Paano nyo punin yung mga loads niya, yung roofs, lights, equipment, partition wall, people, infiltrations, glass solar, glass conduction, exterior wall, and the floor. Wala pa dyan yung ceiling. Okay? So, kung maglalagyan ng ceiling, ito story yan. Ang ceiling is yung o floor slab. Ceiling nito o floor ng upper. Ang roof yung pinakataas. Yung floor yung pinaka-ground. So, ito is, tama, piring kong floor na meron po sa ilalim. Kung sinabing ground floor, yung lupa na to. Objectives ng cooling load mode. Cooling loads calculation may be used to accomplish one or more of the following objectives. In this topic, kasama rin yung heating load pero short lang kasi may lang naman. Ibang calculation ng heating loads may lang yun. Kasi ibig sabihin, lahat ng equipment, ng heat na gamit equipment, piniconsider na as heating load. Cooling load calculation may be used to objectives. A. Provide information for equipment selection, sizing, and system design. Anong size mo? Yung mga galing yan sa calculation. So, B. Provide data visible within the optimal possibility. Ibig sabihin yung mga time. Yung time, ito ba yung cooling load mo, value lang video per hour. C. Permit analysis of partial load as required for system design, operation, and control. Para sa same lang yun ang D. Sabihin ang partial, on, off mo. Kasi kung mababa lang sa umaga, so yung dalawang unit mo, pag nasa peak na, commonly, terminology. Commonly used term relative to heat transmission and load calculation are defined below in accordance with ASCII standard 12-75 refrigeration terms and definitions. ASCII standard yan. Pwede download. Kailangan na natin is terminology. Space is either a volume or a site without a partition or a partition room or group of rooms. Room is an enclosed or partitioned space that is usually treated as a single load. Yeah. Zone is a space or group of spaces within a building with heating and or cooling requirements sufficiently similar so that comfort condition can be maintained throughout by single load supply. Same ang room conditions. Sa mga commercial gan, same lang yan. Bahay, same lang yan. Pwede mo pag-isahin. Unit. Pero sa mga industrial, sa mga iba-iba yung conditions niya. Pinag-grupo yung pare-parehas. So, British thermal unit. So, is the approximate heat required to raise one pound, common ang definition nito, of water, 1 degree Fahrenheit from, okay, 59 degrees Fahrenheit to 60 degrees Fahrenheit. Air condition are rated by the number of BTUs thermal units of heat they can remove per hour. Another common rating for the air conditioning size is the tons. Alam niyo yan, di ba? Kasi diniscusan natin. Which is 12,000 BTU per hour and watts. Some countries utilize one unit more than the others. Therefore, it's good if you can remember the relationship between BTU per hour tons, and watts. So, meron pang iba niya na common sa maliliit, split type, window type na aircon, is yung horsepower. Horsepower is about 3/4, 175.8 of standard. Tingnan nyo lang sa table na catalog. And horsepower na yan is convert pag sa kilowatt ng conversion. 12,000 meter per hour is equivalent to 50 watts or 3.516 watt. This is 3.516 kilowatt per ton. Yun ang conversion nun. So, cooling load, temperature difference, CLTD. Sa cooling load calculations, madalas na gamitin sa method. Isa sa method niya, magamit ng CLTD. Maraming method ng cooling load calculation. Discuss lang natin yung may table. Yung iba kasi software na. O Excel na. An equivalent temperature difference used for calculating the instantaneous external loading cooling load across a wall or roof. Applicable lang sa wall or sa roof. Sensible heat gain is the energy added to the space by conduction, convection, and or radiation. Basta ng temperature, nagdagdag, that is sensible heat gain. Galing sa heat gain, di ba? Galing sa tao. Galing sa wall. Nag-gain ng room. Tapos, yun naman ang lalagyan mo ng aircon para ma-oppose yung heat gain. Latent heat gain is the energy added to the space. Yan, and energy added to the space when moisture is added to the space by means of vapor emitted by the occupants, pawis, generated by a process or through air filtration from outside or adjacent areas. Sa process, yung merong mga pagkain, yung mga product na may hygroscopic, sabihin, nag-absorb ng moisture or nag-release ng moisture. Gulay, yan. Tapos yung mga air infiltration, yung mga leaks sa bintana, pumapasok na outside air. Yan. Meron mga moisture yan. So, ito yung, ang aircon, dryer din. May patak kayo ng tubig sa lamesa, sa air, kung magaling yung aircon, may maya, wala na yan. Nag-dry din. Okay? Radiant heat gain. The rate at which heat is absorbed is by the surfaces enclosing the space and the objects within the space. Minimal lang to. But radiation, magkaiba temperature ng dalawang walls, so magkakaroon siya ng radiation. Space heat gain is the rate at which heat enters into and or is generated within the conditioned space during a given time interval. Ito yung sa heat na gain mo sa room, space. So, space cooling load is the rate at which energy must be removed from a space to maintain a constant space or temperature. So, sometimes this is heat gain is equal to cooling load. Pero may mga hindi efficiency, so hindi masyado nag-equal. Yung cooling load, ito yung isusupply mo. Yung heat gain, ito yung paiba-iba. Kasi depende sa oras, kaya ang given time interval. Yung space cooling load, ito yung aircon mo. Kung fix ang aircon mo, so siyempre may excess yan. Saan napupunta? Na-install sa wall. Sa mga gamit. Tapos pag naman, nagkulang yung tumaas yung heat gain mo, nagkulang yung cooling load mo, doon, i-release naman ng wall mo yan. Yung ibang lamig. Okay? Space heat extraction rate, the rate at which heat is removed from the conditioned space and is equal to the space cooling load if the room temperature remains constant. Ibig sabihin niya. at temperature constant. Temperature, dry bulb, is the temperature of air indicated by regular thermometer. Temperature, wet bulb, is a temperature measured by a thermometer that has a bulb wrapped in wet cloth. The evaporation of water from the thermometer has a cooling effect. So the temperature indicated by wet bulb thermometer is less than the temperature indicated by dry bulb. Normal and modified thermometer. So the rate of evaporation from the wet bulb temperature depends on the humidity of air. Evaporation is lower when the air is already full of water vapor. So for this reason, the difference in temperatures indicated by the ordinary dry bulb and wet bulb temperature gives a measure of atmospheric humidity. And the difference in dry bulb and wet bulb gives a measure of atmospheric humidity. So check nyo lang doon sa mga formula kung paano niya nag-iba na measure. Okay? Sa mga testing ng air conditioning niya, may instrument na sling cyclometer. Okay? Temperature dew point is the temperature to which air must be cooled in order to reach saturation or at which the condensation of water vapor in a space begins for a given state of humidity and pressure. Relative humidity describes how far the air is from saturation. It is a useful term for expressing the amount of water vapor when discussing the amount of and rate of evaporation. One way to approach saturation at a relative humidity of 100% is to cool the air. It is therefore useful to know how much the air needs to be cooled to reach saturation. Next, thermal transmittance or heat transfer coefficient, U factor, is the rate of heat flow through a unit area of the building envelope materials or assembly, including its boundary films, per unit temperature, difference between the inside and outside air. The U factor is expressed in BTU per hour, Fahrenheit square foot, or watts per meter squared Kelvin. And thermal resistance R is the reciprocal of heat transfer coefficient and is expressed in R Fahrenheit square foot per BTU. For example, a wall with U value of 0.25 would have a resistance value of R as 1 over U is 1 over 0.25 or 4.0. So the value of R is also used to represent thermal resistivity and the reciprocal of thermal conductivity. In other terms, conductivity, naman na kay set transfer, di ba? Next. Now, sizing your air conditioning system. So the concepts and fundamentals of air conditioner sizing is based on heat gain and or losses and building. So it is obvious that you will need to remove the amount of heat gain if it is hot outside. Similarly, you need to add in the heat loss from your space if outside temperature is cool. In short, heat gain and loss must be equally balanced by heat removal and addition to get the desired room comfort that we want. So the heat gain or heat loss to a building depends on A, the temperature difference between outside temperature and our desired temperature inside. B, the type of construction and the amount of insulation is in your ceiling and walls. Kung insulation kayo nalagay sa ibang room, diba nalagay ng insulation sa ibang bahay. Let's say that you have two identical buildings. One is built out of glass and the other out of brick. Of course, the one built with glass would require much more heat addition or removal compared to the other given assembly. This is because the glass has a high thermal conductivity U value as compared to the brick, and also because it is transparent. It allows direct transmission of solar. So, letter C. How much shade is on your building's window, walls, and roofs? Meron tayong mga overhang, di ba? Sa mga bintana, sa mga roof, may mga puno, yan, nakaharang sa araw. So, consider mo yon kung detailed yung calculation mo. Consider mo yung mga overhang na yan. Problema, pag tinanggal na. So, tinanggal yon. So, mag-change ka ng design. Two identical buildings with different orientation with respect to the direction of sunrise and fall will also influence the air conditioner sizing. Orientation, north, east, west, south. So may part dyan na mainit, may part dyan na malamig. Letter D. How large is your room? The surface area of the walls. The larger the surface area, the more heat can lose or gain to it. Kailangan mo yung dimension. Inside dimension. E. How much air leak into indoor space from the outside? Infiltration plays a part in determining our air conditioner sizes. Yung mga leak mo, pagbukas yung bintana mo, open, may pasok ng hangin. So, that isa pala, bigyan mo yun, siyempre. So, door gaps, crack windows, chimneys, or are the doorways for air to enter from outside into your living space. So, hindi pa yan. Air leaks. Meron tayong intended na ventilation air, fresh air. Kailangan din yan. F, the occupants. It takes a lot to cool a town half full of people. Siyang tao, meron siyang required cooling din. G, activities and other equipment within a building. Cooking, hot bath, gymnasium. Ano yung klaseng activities mo? Nakaupo ka lang. Nag-jogging ka sa gym. Or busy ka. Diba? Natutulog ka lang. So, iba-iba yung factor niya. So, H, amount of lighting in the room. High efficiency lighting fixtures generate less heat. So, meron tong bilang mo yung ilaw, divide, bilang watts yun, divide mo ng area, so meron ka na per square meter. So, meron ding matinatawag na rule of thumb dito. Kaya lang, mas maganda pa rin yung actual. Rule of thumb is if not available, so use rule of thumb. So, minsan oversize naman yung rule of thumb. Minsan naman undersize. So, kung may reflected ceiling plan yung plano, bilangan mo yung ilaw. So, ilan yung watts nung 100 watts each, divide mo nung floor area. So, meron ka na watts per square meter o square foot. So, meron ka na total wattage ng electrical. So, dadaan tayo dyan. How much heat the appliances generate? Number of power equipment such as oven, washing machine, computers, TV inside the space, all contribute heat. Yan. Yan, pag sa kwarto may oven ka, nagluto ka, wala ka aircon ka, so may, may losses yun na init, heat loss. So, yung heat loss na yan, nag-gain ng room. So, yung room, yun naman ang idadagdag mo sa aircon. Madadagdag yun sa aircon. Washing machine, meron din yan. Kasi nga, may pumapasok na hangin yan. Diba kasi may motor yan, ilalim yan. So, kailangan mag-ventilate mo yung motor. Ha? Computers, madami yan. Laptop, cellphone, may screen, TV, lahat ng inside sa space. All contribute to heat. Yung mga rooms, design, so wala computer, wala kinukusin ng computer. Lately, yung iba, pag may computer, minsan iba, walang lahat. Ngayon, lahat, lalagyan nyo ng additional para doon sa, alam nyo na, laptop, tablet. May mga maliliit na part dyan. Yung ilang watts pa yan na cooling load. Now, the air conditioner's efficiency, performance, durability, and cost depend on matching its size to the above factors. Itong factors na to. Matching. Yung nakuha mo mga load ito, yun ang ikukumpare mo dun sa air conditioner. Many designers use a simple square foot method for sizing the air conditioner. So the most common rule of thumb is to use a 1 ton for every 500 square feet of floor area. Such a method is useful in preliminary estimation of the equipment size. Siyempre, budgetary. Patuloy ko muna. The main drawback of rules of thumb to be noted is the presumption that the building design will not make any difference. Thus, the rules for a badly designed building are typically the same as for a good design. So, check mo lang yung sinasabi rule of thumb applicable dun sa building. Okay? Sa rule of thumb, ginagamit lang yan sa inangan ka ng estimate kung magkano yung budget. So, estimate yung mga rule of thumb. Tapos, yung mga, binigyan ka ng dimension. Anong size ng equipment room? So, rule of thumb. Siyempre, kailangan malaman yung scroll ng HU, yung unit. Tapos, i-reflect mo lang sa plano, mag ng allowance. So, makuha mo na yung size ng room. Okay? Kayong quantity. So, may-reflect mo na. Tapos, pag nag-calculate ka na, so, hindi mo na gamitin yung rule of thumb. So, kailangan yung, mo doon, pumasok sa rule of thumb mo. O malapit doon yung nakuha mo. Plus, ito, check. Tawag na check. Check load. Check load na. Square meter per ton. Yan ang Yan. Check mo na siya. Kailan yung actual mong square meter per ton pag pumasok dito sa estimate mo. Pag tumaas sa estimate mo, so may mali doon sa calculation mo. May kulang. So it is important to use the correct procedure for estimating heat gain or heat loss. So hindi ka pwede magsumbit ng analysis na rule of thumb. May analysis. And then magsumit ka ng analysis, gini sinumbit mo rule of thumb. So mali yan. Okay? Hindi yun analysis. Two groups, the Air Conditioning Contractors of America, ACA, and American Society of Heating, Refrigerating, and Air Conditioning Engineers publish calculation procedure for sizing central air conditioner. So, wala pa ho itong mga ACA na to. Reputable air conditioning contractors will use one of these procedures, often performed with the aid of computer, to size your new central air conditioner. Ginagamit ko is yung hub, yung carrier. Okay? Na software. Maraming software nito. Pero mas maganda yung carrier kasi compact. Kunti lang yung output printing. Iba kasi per room, kapal. So, hindi pa user-friendly. Now, heating load versus cooling load calculation. Magkaiba niya. As the name implies, heating load calculations are carried out to estimate the heat loss from the building in winter so as to arrive at the required heating capacities. Normally, during winter months, the peak heating load occurs before sunrise and other conditions do not vary significantly through the winter season. Pag heating, yun ang luman sa maatab, luman ang pinakamalipot. In addition, internal heat sources such as occupants or appliances are beneficial as they compensate some of the heat losses. As a result, normally the heat load calculations are carried out assuming steady state conditions. Ito lang ng cooling load variable. So dito sa heat load, no solar radiation and steady outdoor conditions and neglecting internal heat sources. Kasi nakakatulong nga yun pag umandar. So, hindi mo pwedeng i-minus paano mo siya i-minus kung hindi naman umandar during that time. So, wala rin heat. Kailang ini-neglect mo lang. So peak cooling niya is yung hindi umaandar yung May cooling, unang malamig, time. Pinakamalamig yung time. Yun ang initin mo, di ba? This is simple but conservative approach that leads to slight overestimation of heating capacity. Yan. Slight overestimation kasi in case nga hindi naman ginamit yung mga appliances. For more accurate estimation of heating load, one has to take into account the thermal capacity of the walls and internal heat sources, which makes the problem more complicated. So, pwede mo isang i-minus. Kaya lang, at the time na hindi ginamit, mas malamig. Diba? Kailangan mo tanongin, kailan mo gagamitin ito? Kailan ka magluluto para magkainit? So, ngayon, meron namang mga inverted type na pwede mong i-adjust. So, for estimating cooling load naman, one has to consider the unsteady state processes as the peak cooling load occurs during the daytime. And the outside conditions also vary significantly throughout the day due to solar radiation. In addition, all internal sources add on to the cooling load, and neglecting them will lead to underestimation of the required cooling capacity and the possibility of not being able to maintain the required indoor conditions. Okay? Underestimation, bawal yon. Nag-design ka na, under-design ka pa. So that is, over is okay, slight lang. Overestimation is slightly is allowed, design. Pero wag naman yung over-design, parang hindi ka na nag-compute. Thus, cooling load calculation are infinitely more complicated. In determining the heating load, credit for solar heat gain or internal heat gain is usually not included, and the thermal storage effects of building structure are generally ignored. Whereas in cooling load calculation, the thermal storage characteristic of the building play a vital role because the time at which the space may realize the heat gain as a cooling load will be considerably offset from the time the heat started to come. Diba? Kaya, sabihin, yung heat gain ng room, yun ang magiging cooling load na aircon. Next, heat flow rates. Heat. Bago gawin nyo dito, CFM, cubic meter pounds per minute. Hindi yan flow rate na mass, that is heat. In air conditioning design, 4 related heat flow rates, each of which varies with time, must be differentiated. A. Space heat gain. How much heat energy is entering the space? Yung walang aircon na mga pumapasok sa space. B. Space cooling load. How much energy must be removed from the space to keep temperature and relative humidity constant? Ito naman isusupply mo. Supply and demand. Supply and demand mo isang heat. Space heat extraction. How much energy is the HVAC removing from the space? Yan. Ito yung sa room. Ito naman yung load ng aircon mo. Cooling load sa coil, ito. How much energy is removed by the cooling coil serving various spaces plus any loads external to the spaces such as duct heating, duct leakage, fan heat, and outdoor makeup air. Yan. Okay. So, this is cooling. Magkaiba yan. Ito kasi mas malaki. Ano to? Ito discuss natin dito. Ito naman yung sa equipment to HVAC. Heat extraction ng HVAC. Ito yung how much energy removed from the space to keep temperature and relative humidity constant. Ito naman yung gain doon sa room. So, magkaiba yan. Kasi yung mayroong mga storage. So, hindi lahat cooling load. Okay. So, space heat gain. Instantaneous rate of heat gain is the rate at which heat enters into and or is generated within a space at a given instant. Heat gain is classified by the manner in which it enters the space. A. Solar radiation through transparent surfaces such as window. Window, glass Glass ibig sabihin niya. Kaka yung bintana nyo, hindi naman window yun. Hindi naman glass yung binubuksan. Inaangat lang. Yan. B. Heat conduction to exterior walls and roofs. C. Heat conduction to interior partition, ceiling, and floor. D. Heat generated within the space by occupant lights, appliances, equipment, and processes. Ang letter C pala, itong partitions, ceiling, or floors, pwede siyang mag-zero kung pare-parehas ang temperature, design conditions ng grupo. At sabay-sabay sila kumata. Okay. Pag centralized, it's okay. Letter E. Loads are as a result of ventilation and infiltration of outer air and other miscellaneous heat gain. Now, whether it is a sensible or latent heat gain. Sensible heat which a substance absorbs and while its temperature goes up. The substance does not change state, so kaya temperature lang. Sensible heat gain is directly added to the conditioned space by conduction, convection, and or radiation. Note that the sensible heat gain entering the conditioned space does not equal the sensible cooling load during the same time interval because of the stored heat in the building and below walls. Yan. Only the convective heat becomes cooling load instantaneously. Convective lang. Sensible heat load is a total of A. Heat transmitted through roof, floors, roof, buildings, and walls. B. Occupants body heat. C. Appliance and light heat. D. Solar heat gained through glass. E. Infiltration of outside air. F. Air introduced by ventilation. So, ito yung mga sensible heat. Next is the latent heat load. Latent heat gain occurs when moisture is added to the space either from internal sources, that is vapor emitted by occupants and equipment, or from other air as a result of infiltration or ventilation to maintain proper indoor air quality. Latent heat load is the total of A. Moisture-laden outside air from infiltration and ventilation. B. Occupant respiration and activities. C. Moisture from equipment and appliances. To maintain a constant humidity ratio, water vapor must condense on cooling apparatus at a rate equal to its rate of addition into the space. This process is called dehumidification and is very energy intensive. For instance, removing 1 kilogram of humidity requires approximately 0.7 kilowatt hour of energy. Space heat gain versus cooling load, heat storage effect. So space heat gain is not equal to space cooling load. The heat received from the heat sources, conduction, convection, solar radiation, lighting, people, equipment, etc., does not go immediately to heating the room. Only some portion of it is absorbed by the air and the air-conditioned space instantaneously, leading to a minute change in its temperature. Most of radiation heat, especially from sun, lighting, people, is first absorbed by internal surfaces, which include ceiling, floor, internal walls, furniture, etc. So, ito yan. So, add the convectivity, diretso. Then, yung iba may store. So, yun ang magiging cooling load mo. Yan, nabalik. So, hindi ito mag-equal. Due to the large but finite thermal capacity of roof floor, roof floor, walls, etc., their temperature increases slowly due to absorption of radiant heat. The radiant portion introduces a time lag and also a decrement factor depending upon the dynamic characteristic of the surfaces. Sa decrement factors, for definition niya, doon na kayo sa vibration engineering nyo, meron doon decrement factor. Wave yan. Due to the time lag, at yung time lag doon sa vibration mo, sa instrumentation, the effect of radiation will be felt even when the source of radiation. In this case, the sun is removed. The relation between heat gain and cooling load and the effect of mass of the structure, light, medium, and heavy, yan ang classification ng mass of the structure ng walls, yan, is shown below. From the figure, it is evident that there is a delay in the peak heat, usually for heavy constructions. Dito. Actual cooling load and solar heat gain for light, medium, heavy construction. So yung light, time, and heat gain or cooling load. So heat gain. Heat gain tayo with the heat gain. Ito yung instantaneous heat gain mo sa susupply na receive. Ito yung actual mo sa light, sa medium, sa so meron siyang time lag ng peak. Dito yung peak ng ano mo, heat gain. So yung peak naman sa light construction, medium construction nandito. So meron siyang time lag. Okay? Now, space cooling versus cooling load. Ang coil, yung actual unit mo. Space cooling is the rate at which heat must be removed from the space to maintain air temperature at constant value. So cooling load, on the other hand, is the rate at which energy is removed at the cooling coil that serves one or more conditioned spaces in any central air conditioning system. It is equal to the instantaneous sum of the space cooling loads for all spaces served by the system plus any additional load imposed on the system external to the conditioned spaces items such as fan, energy, kasi pag nag-increase yung ano niya, yung pressure niya, magka-equivalent niya na heat. So, addition yan sa, sa internal conditioned space called load. Fan location, di ba may heat yan. Duct heat gain, duct leakage, heat extraction lighting system, and type of return air system all affect component sizing. Now, components of cooling load. So the total building cooling load consists of heat transferred to the building envelope, walls, roof, floors, windows, doors, etc., and heat generated by occupants, equipment, and lights. The load due to heat transfer through the envelope is called an external load, while all other loads are called internal loads. The percentage of external versus internal load varies with building type, site climate, and building design. The total cooling load on any building consists of both sensible as well as latent heat latent load components. Dalawa yan. The sensible load affects the light bulb temperature, while the latent load affects the moisture content of the conditioned space. No? Moisture content, the humidity ratio, equal yan. Buildings may be classified as externally loaded and internally loaded. In externally loaded buildings, the cooling load on the building is mainly due to heat transfer between the surrounding and the internal conditioned space. Like mga sa bedrooms na exposed lahat, that is loaded externally. So, kasi yung equipment mo sa room, kasi wala ka naman TV, wala ano, ng iba pa. Patay ang ilaw, so that is externally loaded. Since the surrounding conditions are highly variable in any given day, Since the surrounding conditions are highly variable in any given day, the cooling load of an externally loaded building varies widely. So in internally loaded buildings, the cooling load is mainly due to internal heat generating sources, such as occupants, lights, or appliances. Kung yung dinidesign mong room, hindi naka-expose, nasa loob siya ng building, walang naka-expose na wall sa araw. Okay? That is internally loaded. In general, the heat generation due to internal heat sources may remain fairly constant. And since the heat transfer from the variable surrounding is much less compared to the internal heat sources, the cooling load of an internally loaded building remains fairly constant. Halos constant. Okay. Obviously, from energy efficiency and economics point of view, the system design strategy for an externally loaded building should be different from an internally loaded building. Hence, prior knowledge of whether the building is externally loaded or internally loaded is essential for effective system design. So these are the sources of cooling load. Yeah, kita nyo. Discuss ko na dati. Now, punta tayo sa cooling load calculation method. Ano-ano yung mga method na ginagamit. For a thorough calculation of the zones and whole building loads, thorough detail na detail. One of the following three methods should be employed. A. The transfer function method, TFM. This is the most complex of the method proposed by ASTER and requires the use of a computer program or advanced spreadsheet. B. Cooling load temperature difference, cooling load factor, CLTD, CLF. This method is derived from the TFM method and uses tabulated data to simplify the calculation process. The method can be fairly easily transferred into simple spreadsheet program but has some limitation due to the use of tabulated data. Ito yung gagamitin natin. Manual. CT, total equivalent temperature differential, time averaging, TETD, and TE. This was the preferred method for hand or simple spreadsheet calculation before the introduction of CLTD and CLF method. At the same siya. Ito yung preferred method nung wala pa yung CLTD. Pero ngayon, CLTD na. Okay. These three methods are well documented in ASCII Fundamentals 2001 and 1997. Mas 97, mas detailed. Mas maraming table doon. Accuracy and reliability of various calculation method. For each cooling load calculation method, there are several benefits, limitations, which feature each method. Simplicity and accuracy are two contradicting objectives to be fulfilled. If a method could be considered to be simple, its accuracy would be a matter of question and vice versa. While modern methods emphasize on improving the procedure of calculating solar and conduction heat gains, there are also other main sources coming from internal heat gains, people, lighting, and equipment. Handbooks include tables for the heat gain estimation from the internal sources. However, such tables are incomplete. For example, for equipment not present in the table, only limited information is indicated about them. Sometimes recommendations are mentioned about using 25% to 50% of the nameplate power consumption, where the final value is left to the interpretation of the designer. Yung mga may motor na equipment mo rin, washing machine, hindi naman yung motor, rating ng motor, i-convert mo sa heat, 100%. Kasi naka-cover siya, di ba? Hindi lahat yun ma-expose. So, in other times, it is the accurate predictability of the occurrence is also important. That is, the frequency of using of equipment is very important to determine the heat gain. Paggamit pa ng oras, ganyan. This example of internal heat gain shows that when thinking of accuracy, it is not only the method, simple versus complex, which is effective. But uncertainties in the input data are also important. There are high degree of uncertainty in input data required to determine the cooling load. Much of this is due to the unpredictability of occupancy, human behavior, outdoors, weather variations, lack of and variation in heat gain data for modern equipment, and introduction of new building product and its core equipment with unknown characteristics. For example, yung isang tao, lumipas sa isang room, ibang effect nung galing sa isang room na hindi aircon, galing sa labas, pawis na pawis, pumasok sa, sa room na may aircon. So, malakas ang heat gain, ang heat release niya, di ba? Pero yung isang tao, galing sa air-conditioned room, lumipas sa air-conditioned room, so no heat gain. Considered as no heat release. Hindi natin alam. So this generate uncertainties that far exceed the errors generated by simple methods compared to more complex methods. Therefore, the added time effort required for the more complex calculation method would not be productive in terms of better accuracy of the result if uncertainties in the input data are high. Otherwise, simplified methods would likely have similar level of satisfactory accuracy. Ay, ibig sabihin nga, kung ang data mo ganito lang, so gamit ka ng simple method. Kung maraming siya binigay na data, kompleto, may schedule, may ano, so use the detailed, yung isang approach. So, the more input, mas maano yung calculation mo, complex. Kasi kailangan mo gamitin lahat ng input. Kung kulang input mo, so pwede ka mag-assume o magtingin ka sa mga table na available. Diba? So, the equipment, meron siyang rating ng mga appliances, BTU per hour. Sa nameplate, nakikita mo. So, yun. Okay, may data ka. May input ka. So, pag wala kang din sinabi lang sa'yo washing burner, kaya sa isang appliances lang, walang data. So, tingin ka sa table ng similar equipment. So, for strict manual cooling load calculation method, the most practical to use is the CLTD-SL-CLF method as described in the 1997 ASCII fundamentals. This method, although not optimum, will yield the most conservative result based on peak load values to be used in sizing equipment. It should be noted that the result obtained from using the CLTD-CLF method depends largely on the characteristics of the space being considered and how they are vary from the model used to generate the CLTD-CLF data shown on the various tables. Engineering judgment is required in the interpretation of the custom tables and applying appropriate correction factor. Later. Next, design information. So, mga inputs nyo. Sa Pilipinas, madali lang yan. Ano yung mga input mo sa weather data. Meron tayong standard, Manila, value. Okay. Kapag sa ibang lugar na, tingin ka sa table of weather data. Ayan. So, sa table niya, maraming value. So, ano yung gamitin mo doon? Ayan. To calculate the space cooling load, detailed building information, location, site, weather data, internal design information, and operating schedule are required. Yan. Kung walang operating schedule, so use na typical. Okay? So, pwede mong constant na lang. Information regarding the outdoor design conditions and design indoor conditions and the starting point for the load calculation is discussed below. So, una, outdoor design weather condition. So, ASCII 97 Handbook, 1997 Fundamentals, Chapter 26, list table of climate conditions for the US, Canada, and other international locations. So, in this table, the information provided in Table 1A, 2A, and 3A are for the heating conditions that include A. Dry bulb temperatures corresponding to 99.6% and 99% annual cumulative frequency of occurrence. B. Wind speed corresponding to 1%, 2.5%, and 5% annual cumulative frequency of occurrence. C. Wind energy most frequent occurring with 99.6% and 0.1% rival temperatures. D. Average annual extreme maximum and minimum rival temperatures and standard deviations. So, ito yung table 1A for example. So, dito yung mga, ito yung United States to So, dito yung sinasabi niyang number 1 na rival temperatures 99.6, 0.4%. Ito. 99.6 and 99%. So, dito is 99.6%. Tapos, ito yan. Tapos, wind speed, ito, 1%, 2.5%, 5%. Ito pala yung heating pala tayo na. Heating dry bulb ito. 99.6 and 99%. Letter C naman is yung wind direction. Ito. WS is wind speed, dB is dry bulb, M is mean. So, standard deviation and data. Maximum and minimum dry bulb. Okay. Ito yung table 1A, United States, table 1A, table 1B. Saan naman itong table 1B? Okay. Puro 1A lang tayo muna. Ito yung cooling. Ito naman yung shot cooling and dehumidification, sign conditions para din tayo bumalik. United States, table 1B. Ano ito yung mga ano yan, di ba? Cooling, 0.4%, 1%, 2%. Yan. Wet valve, ito naman. So, ayan. Ito yung range, daily range. Yan, later. Doon na tayo babalik dito. Yan. Yan yung mga range niya. Diba? Hindi nyo na lang dyan. Sa example natin mamaya, ito, Indiana ba yun? Ito yung example natin. Yan. Ito yata. Oh, mali. Ano to pala? English units. Wait. Palitan natin ha. Meron tong ano, SI units pa ito. Meron tong English units. Okay? English units. Pause muna tayo.